Welcome to solverfy.
6.59, we want to figure out what the acceleration due to gravity on Jupiter would be in terms of g on Earth. So this would be, we want to imagine we have a planet the size and mass of Jupiter, but presumably solid, so you could actually stand on it, because Jupiter is a sort of a big heavy cloud more than there being anything solid, although its core might be. But in any event, we can just imagine we have a solid planet the same size and mass and go from there. So we're told that the mass of Jupiter is 320 times roughly the mass of the Earth. Which we're also told is 1.9 times 10 to the 27th kilograms. And that its equatorial radius 7.1 times 10 to the 4th kilometers, and that its rotational period is 9 hours and 55 minutes. We're supposed to take the centripetal acceleration into account. So, if we imagine a free body diagram, so here's a mass of some, a test mass sitting on the surface. We'll have a normal force and then mg. And we know that since this is undergoing circular motion, that m times the g on Jupiter minus this normal force, which is what you'd feel is your weight, has to be equal to the centripetal acceleration, or rather the centripetal force, sorry. And so this normal force is going to be m times the acceleration of gravity on Jupiter minus v squared over the radius of Jupiter. So the acceleration will be the gravitational constant times Jupiter's mass divided by its radius squared, minus the speed squared, which is 2 pi r divided by the period, times the radius. We have the v squared. So this is going to equal the mass times the effective acceleration of gravity there. And so this is 22.94 meters per second squared. Just you cancel out the masses of your test mass because you don't care. what it is. It's just sort of whatever happens to be there will feel this acceleration. And then evaluating this, you get this. And this is 2.3 times the acceleration from gravity on the surface of the Earth. And the question asks, whether, some people have claimed that you'd be crushed from the gravitational force on something like Jupiter, but it turns out that, you would definitely feel, you'd feel twice as heavy, but that's not enough to crush you. So you would be relatively safe, at least in terms of the gravity, even if moving around was a little bit difficult.